This is the screencast for section 2.1, example 4. Transforming the squaring function is our ultimate goal in this example, but first we're going to learn a little bit about quadratic functions. Maybe you already know some of this. So a quadratic function is a polynomial of degree 2. In other words, the highest exponent of x is 2. It has an axis of symmetry. That is the vertical line that goes through the middle of the parabola and crosses through the vertex. The equation of that is x minus h, written right there. I'll explain what h means in a second. The vertex is the minimum or maximum, depending on if the parabola is face up or face down, which we call h comma k. So h is the x-coordinate of the vertex. K is the y-coordinate of the vertex. See what I mean? X equals h. So x equals the x-coordinate of the vertex. Now, a parabola is face up, if you remember this from Algebra 2, if the number in front of the x squared term, so the leading coefficient, is positive. If that leading coefficient is negative, in other words less than 0, then we have a face down parabola. Standard quadratic form is y equals ax squared plus bx plus c. Now standard is boring, it gives us no information. You can use quadratic formula pretty easily with that, which we have very well versed in. The form that I like using the most is vertex form. Vertex form has a coefficient out in front of it called a. Then on the inside of the quadratic, it's got x minus h, then squared, and then plus k. So you recognize h comma k. H is the vertex x-coordinate, k is the vertex y-coordinate. Now if you remember from our transformation section, x minus h really would hold a positive h value because horizontals are the opposite of what you think they would be. So in other words, if this said x minus 3, the x-coordinate of the vertex would be 3. Now if this said x plus 5, then the x-coordinate of the vertex would be negative 5. We're going to learn more about that as we do transformations of quadratics. Speaking of which, example 4. Transforming the squaring function. Describe how to transform the graph of f of x equals x squared into the graph of the given function. Sketch its graph by hand. All right. This first one, let's see, in order of operations, we have two different changes here. We have a vertical flip and a vertical shrink. It doesn't matter which order. So I'm going to say a vertical, we'll go with shrink first, by 1/2. Then we have a vertical flip over the x-axis. Remember, if we flip over the x-axis, we're flipping from top to bottom, which would make that a vertical change. And then we have another vertical shift up 3. So now the original parabola is going to be from 0, 0, just kind of like normal like that. First, it is vertically shrunk by 1/2. So now I'm going to have a shorter, kind of wider looking parabola. Then there's going to be a flip over the x-axis. So I'm going to change that short, wide looking parabola like that. Now we have a vertical shift up 3, which means the vertex is going to change finally. And our final 1, 2, 3, our vertex is going to be at 0, 3, and we're going to have a short, wide parabola flipped over the x-axis and then vertically shifted up by 3. Part B, the transformations that take place are first a horizontal shift, let's see, left 2. Then a vertical stretch by 3. Then we got a vertical shift down 1. Now I can make this a lot more accurate, this drawing a lot more accurate by taking specific points, but the directions say sketch, so I am going to sketch. Alright, so I start with a basic parabola. Next, it's going to do a horizontal shift left 2. So that parabola is going to be about right there. Then we do a vertical stretch by 3. So now that parabola is going to look tall and skinny, but its vertex is going to stay at the same place. When you stretch the y-coordinate 0 by 3, it still stays at 0, because this is negative 2, 0. Now we do a vertical shift down 1, so the vertex is going to move from negative 2, 0 to negative 2, 1. It's still going to be skinny, stretched vertically, left 2, so the vertex is specifically at, let's see, negative 2, negative 1. The now try problem for example 4 is number 19. Number 19 says describe how to transform that function. So let's describe it. First, there is a horizontal shift right 3. Then, only one more, a vertical shift down 2. So the first parabola is our basic one. Then we get a horizontal shift right 3, which is going to move that vertex to 3, 0. Then we get a vertical shift down 2, which is going to move that vertex to 3, negative 2. Now, as you can see, we talked before about in vertex form, you can see the vertex. Look at number 19 here. H, k. We said H, if you see a subtraction sign, would be positive 3 because the subtraction sign comes with the original equation. It's x minus the H coordinate. Well, we are subtracting positive 3. So the vertex would be 3, negative 2. There it is. In example 4, part B, the H value would be negative 2, the K value would be negative 1. Negative 2, negative 1 is our vertex. Now in A, there was no H value. It's like x plus 0 or x minus 0. So the H value would be 0 and the K value would be 3. 0, 3 is our vertex.